Aviation accidents, though tragic, are remarkably rare occurrences, especially in commercial aviation. Technological advancements in aircraft design and stringent safety regulations have made flying incredibly safe. Modern aircraft are marvels of engineering, equipped with sophisticated systems that minimize risks. However, despite these advancements, accidents still happen, reminding us of the inherent complexities and unforgiving nature of flight. While commercial aviation boasts an enviable safety record, general aviation, which encompasses private flying, faces a higher accident rate. This disparity highlights the crucial role of rigorous training, experience, and strict adherence to safety protocols in maintaining the highest levels of aviation safety. Understanding the causes of aviation accidents is paramount in our continuous pursuit of safer skies. The safety gap between commercial and general aviation is significant and demands our attention. In commercial aviation, pilots undergo rigorous training, accumulating thousands of flight hours and certifications. They operate under strict regulations enforced by aviation authorities, ensuring the highest standards of aircraft maintenance and operational procedures. In contrast, general aviation pilots often have fewer flight hours and operate under less stringent regulations. While many private pilots are highly skilled, the lower entry barriers and less frequent flying can contribute to a higher accident rate. Statistics paint a clear picture: commercial aviation accidents are exceedingly rare, while general aviation accidents, though declining, remain a concern. This disparity underscores the critical importance of robust training, stringent safety protocols, and a culture of unwavering vigilance in all aspects of aviation. Human error remains a significant factor in aviation accidents, accounting for a substantial portion of incidents across both commercial and general aviation. While pilots undergo extensive training, they are not immune to mistakes. Factors like fatigue, stress, and complacency can erode judgment and decision-making abilities, increasing the risk of errors. One common type of pilot error is loss of situational awareness, where a pilot becomes disoriented or loses track of the aircraft's position, altitude, or speed. This can occur due to distractions, poor communication, or challenging weather conditions. Another contributing factor is improper aircraft handling, where pilots make errors in controlling the aircraft, especially during critical phases of flight like takeoff and landing. Addressing pilot error requires a multi-pronged approach, including enhanced training programs that focus on decision-making under pressure, improving communication protocols, and promoting a culture of safety that encourages pilots to report errors without fear of reprisal. While modern aircraft are built with redundant systems to mitigate risks, mechanical malfunctions can still occur, leading to aviation accidents. Engine failures, while relatively rare, remain a concern. These can happen due to factors like bird strikes, fuel contamination, or undetected maintenance issues. Beyond engine problems, issues with other aircraft systems, such as electrical systems, hydraulics, or flight control systems, can also lead to accidents. The complexity of modern aircraft demands rigorous maintenance schedules and meticulous inspections to identify and rectify potential problems before they escalate into catastrophic failures. Investing in advanced diagnostic tools, ensuring the availability of qualified maintenance personnel, and adhering to stringent safety regulations are essential to minimizing the risk of mechanical failures and ensuring the highest levels of aviation safety. Section 5. The unforgiving skies weather's impact on aviation safety. Adverse weather conditions pose a significant challenge to pilots and are a contributing factor in many aviation accidents. Thunderstorms, with their violent updrafts and downdrafts, lightning and hail, can be particularly dangerous for aircraft. Similarly, icing conditions can severely impact an aircraft's performance, reducing lift and increasing drag, potentially leading to a loss of control. Fog and low visibility can also create hazardous situations, especially during takeoff and landing when pilots rely heavily on visual cues. Pilots receive extensive training in meteorology and are equipped with sophisticated weather forecasting tools. However, rapidly changing weather patterns and unexpected encounters with localized weather phenomena highlight the importance of continuous situational awareness, prudent decision-making, and a willingness to alter flight plans or delay flights when safety is compromised. Section 6. Loss of control, a critical factor in aviation accidents. Loss of control in flight, or LOCY, is a critical factor in many aviation accidents, often with tragic consequences. This occurs when the pilot loses the ability to effectively control the aircraft's altitude, direction, or airspeed, leading to a stall, spin, or collision with the ground or obstacles. Various factors can contribute to LOCC1, including pilot error, mechanical failures, environmental conditions, or a combination of these. For example, an unexpected gust of wind during takeoff or landing can cause a sudden loss of control, especially if the pilot is not prepared to react quickly and effectively. Preventing LOCY requires pilots to maintain a high level of proficiency in aircraft handling, especially during critical phases of flight. Regular training in flight simulators, which can replicate challenging scenarios, is essential for honing these skills and developing the muscle memory needed to react instinctively in emergencies. Section 7. The perils of takeoff and landing, high-risk phases of flight. Takeoff and landing are the most demanding phases of flight, requiring precision, focus, and a thorough understanding of aircraft performance. During these critical periods, aircraft are operating close to the ground, leaving little margin for error. Takeoffs demand careful calculation of weight and balance, meticulous pre-flight checks, and a keen awareness of environmental factors like wind shear and density altitude. Landings require a smooth approach, precise control inputs, and the ability to adjust to changing conditions such as wind gusts or runway conditions. Statistics show that a significant proportion of aviation accidents occur during takeoff and landing, highlighting the heightened risks associated with these phases of flight. Enhancing pilot training, improving communication protocols between pilots and air traffic controllers, and investing in advanced airport infrastructure such as precision approach systems can mitigate these risks. Section 8. Lessons learned enhancing aviation safety through vigilance. The pursuit of aviation safety is an ongoing journey, demanding constant vigilance, a commitment to learning from past mistakes, and a willingness to embrace new technologies and safety enhancements. Investigating aviation accidents plays a crucial role in this process, providing valuable insights into the causes of accidents and identifying areas for improvement. By carefully examining the sequence of events leading to an accident, investigators can identify contributing factors such as pilot error, mechanical failures, or environmental conditions. This information is then used to develop recommendations for preventing similar accidents in the future. These lessons learned are disseminated throughout the aviation industry, informing the development of new safety regulations, training programs, and aircraft design improvements. The continuous cycle of investigation, analysis, and implementation of safety enhancements is essential to maintaining the highest levels of aviation safety. Section 9. Conclusion. Striving for safer skies, a continuous journey. The pursuit of aviation safety is a shared responsibility involving pilots, airlines, manufacturers, regulators, and the traveling public. While technological advancements and stringent safety regulations have made flying incredibly safe, accidents still occur, reminding us of the inherent complexities and unforgiving nature of flight. By understanding the causes of aviation accidents, learning from past mistakes, and embracing a culture of continuous improvement, we can strive to make the skies even safer for everyone. Embracing new technologies, enhancing pilot training programs, and fostering a culture of open communication and transparency are essential to achieving this goal. As we move forward, let us remember that the pursuit of aviation safety is an ongoing journey requiring unwavering dedication, a commitment to excellence, and a shared passion for making air travel as safe as humanly possible.